infinite horizon model is developed by Ramsey Cass Cookman. In this model, infinite time period is considered. Output and growth of the economy depends upon the behavior and decision of the individual. Total output, labor supply, consumption determined by this model, and in this model macro fluctuation also considered, and macro fluctuation determined by the output of the economy. And this model also developed the macro behavior, and this is dynamics or infinite horizon model because we don't know the end period. So this model taking decision in regards to labor supply, consumption, production, etc. And the growth of the labor is denoted by L, and the growth of the knowledge of the efficient labor is denoted by A, and output will be in the economy depends upon the individual decision to supply for production that affect the total output of the economy. And previously I denote that A, that is growth of knowledge, A, that is growth of knowledge, depends upon the rate of growth of technology, and here the household's objective is to maximize utility given the labor supply, and the farm maximize output that affect the total output of the economy. And the model is considered infinite horizon because there is no end or horizon, so we are concerned it is very much dynamic. How long the number of members will live, there is no finite time at all. And in this model the objective is or some assumption that the farm rent capital and hire labor, and the household provide labor, and farm produce output, and the household provide labor, and they consume the output. Now we are coming to the model that here the population grow exogenously at rate n. The time period is infinite, that is why we consider t is equal to 0, 1, 2, 3 up to infinity. 1, 2, 3, that means first period, second period, third period, and infinity. The utility function that is denoted by u, that depends upon the consumption level with time, that is denoted here that uc of t, and the utility function is integration 0 to infinity e power minus rho t multiply uct lt divided by t dt. Here ct is consumption of each member at time and time t, and e power minus rho t is discount factor, and uct is discounted because to getting next period utility, that is why uct is discounted. And the power rho e, here e power minus rho t is the time period, and rho is the discount rate, but the discount rate of utility is subjective because utility is subjective. and it measures the satisfaction level. So rho is subjective discounted rate. If rho is more, then individual provide more weightage on future satisfaction, and if rho is less, then the individual provide less weightage on future, and that means individual provide more weightage on her consumption in the present period. And in the utility function LT, its total population in the economy, and H is the number of the member of the household. Now UCT is equal to Ct power 1 minus theta divided by 1 minus theta. Here theta is greater than 0. So why theta considered? Because theta is a degree of relative risk aversion. If theta is 0, that means utility function will be linear, but if theta is greater than 1, so the marginal utility of the consumption is positive. So theta, it's a parameter. Theta determine consumption from one period to next period. That means consumption is discounted because we don't know the next period consumption. That is why we discounted the consumption by theta. And the other thing is that the real wage rate of T, that is denoted by WT, and WT is equal to AT. A means the effective A means the technology of the effective labor. So WT is equal to AT square bracket F prime KT minus KT into F prime KT. Real wage rate of time T depends upon the growth of technology. That means AT, growth of technology. So small wt equal to capital WT by AT. Here F dash KT minus KT into F dash KT. Here small wt is the per unit of effective labor. So the term WT, small CT, the per unit wage is per unit of effective labor, consumption per unit of effective labor, that is needed for our household budget constant. In the budget constant, we can see that the present value of lifetime consumption cannot exceed the initial wealth and the present value of lifetime labor income, that is considered in the next slide, that is here. So integration e power minus rt into ct into lt by h dt is less than, that means the present value of the lifetime consumption and it's less than the present value of the lifetime income plus wealth, initial wealth. That is initial wealth is denoted by k0 by h plus integration 0 to infinity e power minus rt wt into lt by h dt. So here this term rt, here r is the discount of consumption, or this rt is discount of consumption. So the budget constants can be written as k0, that means initial period wealth divided by household plus integration 0 to infinity e power minus rt bracket wt minus ct into lth dt is greater than equal to 0. It is coming from the next previous slide. If we this term is taking in the right side, and then we will get this full equation, this equation, and this kt already said that it is an initial wealth, and the e power rho t rt and multiply it with wt, this term is discounted wage rate. Now we are coming to the household maximization. Household's objective is to maximize utilities subjected to the budget constant. So small t city it's equal to capital city by 80, and the consumption, the small city, what is small city? Small city is the per unit or consumption per unit of effective labor, or ct, capital city equal to small city into 8e. It's denoted by the consumption per unit of effective labor. So the household's utility becomes ct power 1 minus theta by 1 minus theta equal to 80 into ct power 1 minus theta by 1 minus theta. So we already said that utility is a function of consumption with time, that is equal to ct by 1 minus theta, ct power 1 minus theta by 1 minus theta. Here ct, we look at the previous slide, we are getting that this equation, uh, that is city, capital city equal to small city, 1 to 80. We are putting this value here. So just replace the value of city and getting 80 into ct whole power 1 minus theta divided by 1 minus theta, and ct power 1 minus theta by 1 minus theta is equal to a0, that is initially knowledge of the labor, into e power gt and square bracket, whole of square bracket, power 1 minus theta by 1 minus theta into ct power 1 minus theta, and here we just use the value of at, that is equal to a0 into e power gt from previous equation. the this value we put here. So a0 it's technology, g is the rate of growth, it is the growth at time t from growth model, and at is equal to a0 into e power gt, taking log both side, and we get a0 plus gt from the previous utility function, that u is equal to integration 0 to infinity e power rho t uct into lth dt, and here we write the same equation and giving a name, that is b, and here putting the value of uct, that is ct power 1 minus theta by 1 minus theta in the utility function from a and b. So look at the equation a, this equation is a, and equation b is this equation. and using this equation a and b we are getting the utility function, and where lt by h is equal to L0 e power nt by h already put here, and utility is integration 0 to infinity e power rho t a0 1 minus theta e power gt 1 minus theta into ct 1 minus theta power and 1 minus theta into L0 e power small rt by h dt. Here a0 1 minus theta into L0 h integration 0 to infinity e power rho t 1 minus theta gt into e power nt into small c t power 1 minus theta by 1 minus theta equal to u. We are getting the utility function. If we successively follow the step, it will be much more clear, but I am using this kinds of board work that is somehow little bit difficult. If written in a copy, then successively then the steps will be much more easier. But here I consider that utility is equal to b integration 0 to infinity e power minus beta t ct minus ct power 1 minus theta by 1 minus theta. Here b is equal to a first bracket 0 1 minus theta L0 h, because it is constant term. We are taking it outside the bracket, outside the integration. And next beta is equal to rho minus n minus 1 minus theta into g. From this equation, now the budget constants has integration 0 to infinity e power beta t ct lth dt, it's less than k0h plus integration 0 to infinity e power capital rt wt into lth into dt. And here the capital ct is equal to the capital ct, it's equal to ct into at, capital wt equal to small wt into at, and k0 initial period capital is equal to small k0 h0 l0, and k0 capital at the initial period already said, and use the equation 3. This is equation 3. Sorry, the above three condition, that is ct wt and k0 is used here, that is integration 0 to infinity e power minus rt ct into at into lt divided by h into dt is less than equal to k0 a0 l0, in place of k first bracket 0 by h, here replace the value of k0 a0 l0 plus integration 0 to infinity e power minus rt wt into at into lth dt. At is technology at period t. Now lt at is equal to a0 l0 into e power n plus g into t. So here we get at, lt, and that means at into lt is equal to a0 into L0 into e power g plus nt, that use for some equation. That is why here consider at into lt. And integration 0 to infinity e minus rho rt into ct into at lt by h dt is less than equal to a0 k0 l0 by h plus integration 0 to infinity e power rt wt at into lt by h into dt, at lt by h dt. That's given, that is put a name, that is star. Next, thus putting L0 A0 E n plus gt in place of ATLT and dividing the equation by A0 into L0 by H, we get this value, that is integration 0 to infinity e power minus rt into ctat by h dt, it's less than k0 a0 l0 h plus integration 0 to infinity e power minus rt into wt at ct divided by h into divided by h dt. And now putting the values, and now the value will be much more smaller from the previous equation. And integration 0 to infinity e power rt ct a0 l0 e power nt n plus t into n plus g into t divided by h, and that is that equation, in that value is divided by a0 l0 by h is in denominator, that is why multiplied h and cut down h and above the value a0 l0, and in below a0 l0 is cutting, uh, it's less than equal to k0 a0 l0 by h a0 l0 by h, both the term is cancelled out, plus integration 0 to infinity e power minus rt small wt e power n plus g into t dt. So the value is integration 0 to infinity e power capital rt ct e power n plus g t dt, it's less than k0 plus integration 0 to infinity e power minus rt small wt e power n plus gt dt, that is provided name, that is double star. And the household's problem is to choose the path of consumption to maximize the lifetime utility such that the budget constants of equation double star, and then utility function taking Lagrange, and lambda is a parameter, and b is b into integration 0 to infinity e power minus beta t. We know that what is the value of b and what is the value of beta, already discussed, into ct power 1 minus theta by 1 minus theta dt plus lambda is a Lagrange multiplier, in the square bracket, that is put the value k0 plus integration 0 to infinity e power rt wt e power n plus gt dt minus integration 0 to 0 to infinity e power minus rt. Here forget to mention the minus value. And integration 0 to infinity e power minus rt c n power n plus e n plus gt ct into dt. Taking derivative with respect to ct and getting the value, and taking derivative with taking log b minus beta t minus theta log c. From the previous equation, that taking log, that is why both side, that is why log lambda minus RT log E. Log E value is 1, that is why I don't write did not do not write the term log E. We know the value is 1, that is why not show in this equation, plus also taking log, that is why plus n plus g into t log E. We know log E value is 1, so the next step is log lambda, and taking integration, tau is equal to 0 to small t, and rt d tau plus n plus gt, giving a name of this equation, that is C. Capital RT equal to small rt into d tau, tau value in between 0 to t, that is why in the integration part here consider the integration value is from 0 to t, tau value is 0 to t, rt d tau, and the capital R is the rate of discount of consumption with time. Now taking derivative of equation 2 with equation C, taking derivative with respect to t, we are getting minus beta minus theta into ct by c dot t by ct is equal to minus r small rt plus n plus g into t, and ct small ct by ct, c dot t by ct is equal to rt minus n minus g minus beta, and rt minus rho minus theta g by theta. Here we know the value of beta is equal to minus n minus g minus theta g, cutting plus n minus n plus g minus g, and ultimately c dot t by ct is equal to rt minus rho minus theta g by theta. So c dot t by ct is equal to a dot by a plus c dot by c, a dot by a it's g, plus we know the value of c dot by c, it's putting here, and ultimately theta g plus theta g minus theta d cancel out and get rt minus rho by theta, and c dot t by c, it's the rate of change of consumption path. All the households are same same, so the equation D shows path of consumption as a whole, since RT small rt is equal to f prime kt, so the rate of interest, that is RT, is equal to marginal cost of capital, that is f prime kt. In equation D, G, the growth rate, it's constant, and rho and theta, it's a variable. If c dot t, that is the rate of change of the consumption path, is equal to 0, that is c dot t is equal to 0, k is equal to k star, then marginal cost of capital f prime kt is equal to rho plus theta g. And here y is the rate of growth of technology A. There is a negative relationship between consumption and technology, but when k is equal to k star, then c dot t by ct is equal to 0. In this diagram, in the vertical axis consider consumption, the horizontal axis consider the capital. K star is optimum level where C dot T is equal to 0 and any point below K star, that is K is less than K star, where consumption is movement upward, and when any point above K star, that is K is greater than K star, then the consumption movement downward. So C dot is less than 0, that means for this zone, marginal cost of capital F prime kt is less than rho plus theta g, where k is greater than k star, and if C dot t it's less greater than 0, that means for this zone marginal cost of capital is greater than rho plus theta g, where k is less than k star, and k dot is equal to the actual investment minus break-even investment. That means k dot t is equal to fkt minus ct minus n plus g into kt. K dot t is equal to 0, then ct is equal to f minus n plus g into kt, and c is increasing until fkt minus n plus gkt, fkt it's equal to n plus g into kt, and then decreasing. When C, this consumption exceeds the level but yield K dot is equal to 0 when K is falling, and this zone K is increasing, for this K is decreasing, and at this level K dot is equal to 0, and K dot rate of growth of capital, and C dot is the rate of change of consumption path. C dot increase up to K is equal to 0 at this level. C is increasing up to this, where K is increasing, and after that K dot is less than 0. C is increasing up to K is equal to 0. So in this diagram, that there is 4 zone. In this zone, red tick, here consumption positive and capital it's positive, so consumption movement is upward and capital movement is to the right. For green tick, here consumption is positive but capital is negative, that is why consumption path move to upwards and the capital move to the leftwards. For this zone, consumption positive but a little bit mistake is there. This blue tick zone, there is consumption capital is both are negative. That is why consumption moved downwards and capital moved leftwards. But for yellow tick zone, here capital positive but consumption is negative. That is why consumption moved to the downwards and capital moved to the rightwards. In the last figure, where k dot c dot is equal to 0, k star is defined as f dash k star is equal to rho plus theta g, and the golden rule is defined as f dash k golden rule is equal to n plus g, number of population plus growth rate. Since the cost of capital, that is f prime k, is less than 0, then k star is less than k golden rule, and then rho plus theta g is greater when k star is less than, k star is optimum capital, that is less than capital at golden rule, then rho plus theta g is greater than n plus g, and from this inequality we get rho minus n into 1 plus theta g is greater than 0. And now come to the last part, that is saddle path. Here observe some movement how to get the saddle path in this model. At point here the k is k star optimum, k0 is less than k star. So for the line k0, the point A, k dot less than 0, c dot greater than 0, k dot is equal to 0, c dot is greater than 0. Point C, k dot is greater than 0, c dot is greater than 0. For H, k is greater than 0. D point, k is greater than 0 but c dot is greater than 0 as well as. And F is k dot is positive and c dot is positive. But point D, both are positive for the zone where k0 is less than k star, but after a point like this point, from this point here, C is negative. C is negative from this point, from this particular point. That is why the path is downwards. For point A, path movement is upward but left sideways. At D, it is also increasing but left sideway. And C, that is backward bending, but only the point D, the movement is to a path we are getting, and it's converge. So at F, where C is rising, K is rising and converge to K star ultimately, and converge to F dash K star is equal to rho theta G. The only path from F is possible to be a saddle path, and economy will converge. So F, starting from F, we are getting this path is saddle path.